Now let's see pulse width modulation. So for pulse width modulation also, we need pulse as a carrier signal and any other signal as a modulating signal. So let's see that what carrier signal we have. So I just check it here. So I am having this 16 kilohertz pulse as a carrier signal, and now let me connect and let me check what modulating signal we are having. So just connecting, this is a modulating signal what we have. So this is the modulating signal we are having. So I can simply change its amplitude and the frequency. So this is what the modulating signal what we have. So let it be. So this is the modulating signal what we are having. Now let's connect again this to the pulse width modulation circuit. So we are just connecting 16 kilohertz pulse to the pulse input of pulse width modulation, which is a carrier signal. Let's connect the modulating signal to the input of pulse width modulator, so which is a modulating signal. And now let's see the output of pulse width modulation output. Now this is, we can see it on channel 2, or let me go for say auto set. So we can see easily that this is the sine wave and this is the pulse width modulated output. Now to be seen more precisely, let me say change this time base further, and I just stop it. Now you can see that when amplitude is going down, the width is very small, and when the signal is increasing, you can see that when the signal is increasing on the positive side, you can clearly distinguish that yes, the width is changing. So this pulse width is changing. So this is how the pulse width modulation signal is, right? So on negative side of the signal, the pulse width is very small. When you go on the higher side, you can see that when you go on the higher side of the signal, the pulse width is increasing. I can again change, so let me go back again. You can also see that if I change its amplitude, you can see that if I change its amplitude, you can see that modulating signal's amplitude, the width is changing. So this is how the pulse width modulation signal. Now let's see it with 32 kilohertz pulse as a carrier wave. So I'm just connecting it here, 32 kilohertz as a carrier signal. So right now the signal is with 32 kilohertz as a carrier frequency. Now let me go for the auto set. I can see that this is the carrier signal, this is my modulating signal, this is my modulated output. Let me simply stop it. So I simply stop it. Now you can see that the width, when signal is down, you can see that the width of the pulses is very low. But when signal is going positive side, you can see that the width of pulses is increasing. So you can see that pulse is low width, pulse width high width, and this is how this pulse width modulation takes place. Again the signal is going down, so again the width of the pulse is going down. So you can see that again the width of the pulse is going down. So this is how you can see, or we witness that the width of the pulse is changing by the instantaneous value of the modulated signal, and this is how the pulse width modulation is.